है ना एसपी वाला अप्लाई करूं रुचि सोया
webinar series.
मैं Alexa बोला थी
खाजवू नको आता.
Happy winning, madam.
Good evening.
शायद इस
Good afternoon, ma'am.
Good afternoon.
Welcome. And our resource person has already joined, Ruchi Kumar.
Hello, Ruchi Kumar.
Ruchi, you're there? I think she'll come a little later. I guess. Good afternoon, Father.
Good afternoon. Good afternoon.
Good afternoon, Father.
Good afternoon. Good afternoon.
We can see you.
Yeah.
Next.
So it is 4 o'clock and let's begin. Welcome participants, students. We have our principal, Dr. Susama Samuel, and our manager, Father Blaise D'Souza, and our resource person, Ms. Ruchi Kumar. I will request our principal, Dr. Susama Samuel, to welcome all of us to this mathematics webinar series 5 on strategies and solutions for boosting mathematics learning. Ma'am.
Yeah. So, good evening, Dr. Vinny, and good evening, Father or Manager Blaise. and all those who are present here on behalf of St. Xavier's Institute of Education. I welcome all those who are present here to attend this webinar series, free webinar series that is on strategies and solutions for boosting mathematics learning. So a warm welcome to this webinar. This mathematics webinar, it is the initiative of Mathematics Pedagogy Unit under the leadership of Dr. Vinny Sebastian, Associate Professor of St. Xavier's Institute of Education, and also along with her, the Mathematics Pedagogy Unit students, with the objective of developing mathematics education, or we can say that promoting mathematics education to develop interest in teaching mathematics and learning mathematics, because we know that mathematics is a difficult subject mostly. That is, so how to develop interest in mathematics as well as how to develop interest in mathematics teaching. So for the past 2 years, this webinar series is going very successfully. I can say that this series, it is the 5th one. That is what the screen is showing. And it is going very well. I can say that it is a success. We started the first mathematics free webinar, and it was a free webinar. And then we moved to, we can say that we have diversified it. It is now involved in research also, and different strata of people are involved in it. Teachers are there, teacher educators, students, and also from different parts of India, different parts of world, there are people are involved in it. So it is, we diversified into different areas now. So I think it is still, it will be going ahead with some other plans. So today's topic for this session is reflective teaching in mathematics. So when I saw the topic, I was very happy because the first part, reflection. Why I was very happy, I know that Dr. Vinny also knows that reflection is a part, I can say, I cannot say part, it is the whole and soul of SXI. So because it is the best, like in a best practice of our institute, reflection, and also I can say that reflective practices or reflection is the strength of SXI. And when I read the topic that reflective practices is today's topic, today's session for this maths webinar, I was very happy because reflection in our institute, reflection before any activity and after any activity, this practice is the reflection is a practice of our institute, and it is unavoidable. So it is very familiar to us as far as different activities and different teaching learning are concerned. So I was very happy for this topic. And today's thing is something different because today's reflective teaching in mathematics subject. Mathematics subject, we all know that mathematics subject, it is in different difficulty levels, we all are experiencing, but mathematics teaching and mathematics learning, I think both need continuous reflection on that particular subject, because most of the time when we teach, especially when we teach mathematics or any subject we teach, we think that we are experienced, so we don't need any reviewing or any reflection. That is what generally that is the belief of a teacher, because I am very experienced, so I don't know any reflection, I don't know to review it, I don't need it because my experience is sufficient enough to teach the subject. That is it is a common belief or a concept, or it is a I can say that it's a belief in our mind. But reviewing and reflection, there are two ways I think I feel we can modify our own. One is by looking at others, we can modify and we can improve upon our teaching. The second one is, I think, by reviewing and reflecting also we can improve upon our teaching. So I think today's our resource person is going to speak on how to improve upon through reflecting upon our own practices. And as far as mathematics teaching is concerned, I think so for teaching of mathematics, every stage of mathematics need reviewing and reflection, because that is very important part of it. It may start from starting to prepare a topic or you are doing the preparation. From that stage onwards, I think so reflection is very important with the what are the objectives of that particular lesson, what are the activities you are going to assign for the students, how do you go about, what are the classwork, what are the evaluation things we are doing. So I think so every stage reflection is very important as far as mathematics subject is concerned, because mathematics is such a subject. So today's our resource person, I know that today's resource person Ruchi Sunil Kumar will be able to tell us more about on this, because she's an experienced person from Tata Institute of Social Science. So we will wait for her, the best way she will tell us the best way of reflecting on mathematics teaching. So I welcome today's resource person Ruchi Sunil Kumar to this session, and also I welcome all those who are present here to attending this webinar, and also I welcome Dr. Vinny Sebastian and her team of students, and I appreciate the effort Dr. Vinny is taking it. Also, I was thinking that I will tell the mathematics students to see whether this webinar, you are conducting it very successfully, whether it is reaching to all those who need it, to school students, school teachers and all. So all the best to everyone, those who are attending it, and thank you.
Thank you, ma'am, for the warm welcome. This mathematics webinar series started in June 2020. Second. Okay, this mathematics webinar series started in June 2020 and during the lockdown, and we continued having monthly sessions. This year we had bi-monthly sessions, and this is the 5th webinar series of the academic year 21-22. This mathematics webinar series, with its main aim, strategies and solutions for boosting mathematics learning, was conceived by the Mathematics Pedagogy Unit for spreading mathematics knowledge and strategy to improve maths.
No sound.
I was muted. Okay. The mathematics webinar series started in June 2020, and we continued having monthly sessions. This year we had bi-monthly sessions, and this is the 5th webinar series of the academic year 21-22. This webinar series, with the main theme strategies and solutions for boosting mathematics learning, was conceived by the Mathematics Pedagogy Unit for spreading mathematics knowledge and strategies to improve mathematics learning. The problems of mathematics teaching learning were discussed on this platform, and many teachers and parents, student teachers have benefited through this webinar. We would like to continue the association with all the participants of this mathematics learning through our mathematics YouTube channel, Mathematics Learning, and the communication with us can be done through the email ID mathslearning@sxi.in. As usual, we have a small research study which will be presented today after the main session. And today we have with us, as ma'am has already introduced, our resource person, Ms. Ruchi Sunil Kumar, from the Center of Excellence in Teacher Education, TISS. As our principal has already told all of you, that reflection is a main part of our teaching learning and all our activities at St. Xavier's Institute of Education. At St. Xavier's Institute of Education, we follow a teaching paradigm, which is called as the Ignatian Pedagogical Paradigm, where we follow 5 stages: knowing the context, providing the experience, reflecting on the experience, designing a meaningful action that emerges out of the reflection, and then evaluating the growth of self and the entire experience. So this is the paradigm that we follow at the St. Xavier's Institute of Education. And as ma'am said, that even I was very happy when I saw this topic on the TISS website, and I immediately contacted Ms. Ruchi Kumar, and she was very kind enough to agree to give the session for our mathematics webinar. So thank you, Ms. Ruchi, again for coming here. And I request Nilsima Almeida to introduce Ms. Ruchi Sunil Kumar for us.
Yes, ma'am. It gives me an immense pleasure to introduce our guest speaker today, Ms. Ruchi Sunil Kumar. Ms. Ruchi is an assistant professor at the Center of Education, Innovation and Action Research at Tata Institution of Social Science, Mumbai. Ma'am holds a PhD degree in mathematics education from Tata Institution of Fundamental Research and a master's degree in education from the Department of Education, Delhi University. She is currently Maths TPP lead in the Connected Learning Initiative. She has designed and facilitated workshops for mathematics teachers and teacher educator in several states, along with participation in design and research on learning outcomes for blended ICT-based students module on the key topics like geometric reasoning and proportional reasoning. She has also taken a session for teacher educators in workshop courses at Homi Bhabha Science Center for Education and Dignator. She has designed several learning courses for maths teachers, including reflective mathematics teaching. Ma'am has published and presented a research at several international and national conferences and has also peer-reviewed the publication in a reputed journal. She is a member of International Group of Psychology of Mathematics Education and Mathematics Teacher Association of India. Her research interests are analyzing interaction between beliefs, knowledge, and practice, identifying supports for professional growth of a teacher, and engaging teacher as a designer. She has experience of working as a primary school teacher for more than 6 years and considered it as a resource for the reflection and inspiration of her work. Today, we are honored to have you, ma'am, and on behalf of the staff, students of St. Xavier's Institute of Education, we welcome you, ma'am. Over to you, ma'am.
Yeah, a few instructions before we begin. So we have the session going on, so please mute yourself when the session is going on. The question answer session will be taken up by Rachel, Susan and Blith. So ma'am, we will be giving you the questions which are, written by the participants on Zoom as well as on the chat. So over to you, ma'am. Thank you.
Thank you so much, Nilsema, for the introduction. Thank you, Vinny Sebastian, for contacting me for this and giving me an opportunity to talk to all the people here at St. Xavier Institute of Education. And thanks, Principal Susama Samuel and Father Blaise D'Souza for facilitating this really good series of workshops for mathematics teachers. We at Tata Institute are also working to have such kind of workshop series for teachers, but I would say that, we need more and more such interventions to not only support our teachers, but to give new ideas so that they are able to implement those ideas in their classrooms. So I want to thank you all for this opportunity. I am, as Nilsema has introduced, I am working in TIS, mostly in maths teacher professional development. And let me share my screen. Yeah. Give me a minute.
Yes, we can see us.
This, you can see my screen, I hope.
Yes, we can see.
Okay. Yeah, so at Center of Excellence, we are working in several areas for supporting teachers. And since this workshop, this webinar is focused on reflective teaching in mathematics, I just want all of you to spend half a minute thinking about, what are the different aspects of teaching of mathematics that one would have to reflect, what are the things that we need to reflect upon? So if there are any students here in the Zoom call with us and they want to say any points, they can write it on chat, they can unmute and they can speak. What are the different things that you think we need to reflect on? If we need to adopt this reflective teaching as a practice. Would anybody like to give a response right now?
Yes, ma'am. There can be methods in teaching of mathematics, the method which we
Methods.
follow.
Okay. So what do you call this method? Would it be same as pedagogy? The pedagogy adopted?
No, not exactly.
Okay.
They are the specific techniques which can be used while
Okay.
teaching.
Okay. And how do you differentiate between method and pedagogy? Why are you saying that it is not the same?
As per me, pedagogy is more wider term. It will
Okay.
include everything like syllabus, the curriculum, and how it is. And as per me, method means a specific way of like teaching one concept, reaching it to the students.
Okay. Okay. Thanks a lot for
I'm
your
not
response.
sure if I'm correct.
Yeah, thanks a lot for your response. And no, it helps me also to understand a little bit how you are thinking. And if there is anyone else,
yes, there is one more answer by Vikas. He says reflective teaching means looking at what you do in the classroom, thinking about why you do it, and thinking about if it works. A process of self-observation and self-evaluation.
Yeah. So this is a very beautiful response. Thank you, Vikas, for this response. And let me share the points that I have for today's webinar. So in this webinar, I am going to share a model of role of reflection in teaching of mathematics. Then we are going to delve into the beliefs, the kind of beliefs that we hold. And these beliefs can be about mathematics itself. What do we consider as mathematics and what do we not consider as mathematics? Because when you're thinking about mathematics classroom, it is important to see, what is it that we consider mathematics? Because there is a lot of mathematics which is happening in our daily life, but it doesn't come into the classroom. And we need to question and reflect as to why we do not consider that as mathematics itself. Then we need to also reflect on our beliefs about the teaching learning process itself. What do we consider as learning? We also need to reflect about the ability of students. We may think that we can't do mathematics, it's not for us, and only some people who have this inborn ability can do mathematics. So I would introduce an idea about growth mindset, which basically is about that anybody can develop a skill or even learn mathematics at any point of time if one takes an effort towards learning it, and if the proper conducive environment is provided. So but one needs to believe that it is possible to learn, and this has to be done both at the part of the teachers as well as students for it to work. Then we will further move on to reflection on the task which are used in teaching of mathematics, reflection on the pedagogy, and reflection on the resources which are used for teaching mathematics. In the second part of the webinar, I will share the kind of courses that we have in TIS, in which we engage teachers in reflective teaching. We support their reflective teaching. And I will also share a little bit about the School Synergy Workshop series, which is very similar to this effort that you are doing here, in which we have also engaged teachers in for the over last 2 years to think about not only mathematics, but also other topics related to English, social science, and various other topics, and even discussion about it. So let us move forward. Yeah. So this is a very basic model that I want to talk about what is the role of reflection in the teaching of mathematics. So we all hold certain beliefs, as I talked about mathematics, about teaching learning, about the pedagogy itself, how we should teach mathematics. And these beliefs are formed as a result of the kind of experiences that we have had in our own schooling, in our own society, and also through social interaction. And within that, of course, books are also a kind of interaction with the author's, point of view. So that will also, reading books will also come into that. Now, why belief has been, if you research, if you see mathematics education research, you will find that belief has been a very important topic of research also, because mostly when we try to analyze why a certain reform has not worked, and why, sorry, somebody needs to be muted. Yeah. So why certain reform is not working? We find that, it is because the teachers' beliefs are very resistant to change. It is why they are resistant to change, because they are there in the society, and whatever ideas are prevalent in the society, teachers also sort of adopt it. They hold on strongly to it, and it becomes very difficult for them to change it if the society itself is not changing. So somewhere we need to think about, whatever change that we want to bring in the classroom is a kind of a societal change, and it will involve a lot of reflection, both on the part of the teachers, on the part of the administrators, as well as on the part of the society, which includes parents. So what happens is, when we reflect on beliefs, the knowledge of what we consider as mathematics, what we consider as pedagogy and learning, that sort of gets enhanced, because through how do we do this reflection? We reflect by thinking about our actions that we have been performing. We reflect by talking to each other, talking to your peer, talking to your superior, getting some guidance from them. We also reflect by writing about our experience. So in all this process, this knowledge gets enhanced, and this knowledge is then reflected in the different activities and different aspects that we engage in while teaching mathematics. These aspects can be tasks and questions that we are using in the teaching. It could be resources, it could be pedagogy, it could be classroom interaction. Just give me a second. I forgot. Just give me one. Okay, so moving forward, what happens is, we do not consider that this process is just a linear one, where through your beliefs are formed through an experience. When you reflect on it, your knowledge get enhanced, and then it gets reflected into teaching. We also need to understand that this action and reflection is sort of a two-way process. It keeps on going in a cyclical manner. So when we actually teach and we think about it, we reflect on it, again, it sort of has an impact on the kind of beliefs we are holding. And it has been found that, when teachers try out something new in their classroom and they find that, students have improved in their performance, it does has an impact on the kind of beliefs that they're holding. So initially they may be sort of resistant to use of ICT resources, or resistant to use of certain kind of tasks, but after they see improvement performance of students, they might be more open to using it further. And not only, I would say, the beliefs, it also improves the knowledge of these aspects of learning, pedagogy, as well as mathematics. So consider this as a cyclical process and not as a linear one. Okay, that is an important aspect that one needs to remember, and that action and reflection goes on hand in hand, and whatever action we do, we need to completely keep on reflecting on it as we move forward. And what model that Vinnie Sebastian had shared in the beginning, I think that is an excellent model to support one's own professional growth in learning, professional growth in teaching of mathematics itself. So let us first reflect on the kind of beliefs that we hold. Okay, so these are a few statements that I'm sharing with you. And what you can do is, I'll read it. And as I'm reading it, you can write for number 1, you agree or disagree, and then you can type it out in the chat itself so that all of us are able to see. So we will get a sort of understanding of what, what is the way people are feeling about these kind of statements, and whether they agree or disagree about it, what kind of beliefs they hold. Okay. So first one is the explanation of mathematics is limited to explaining the steps for solving the problem. I need to move this a little bit. Yeah. Okay. Vinny, you will have to read what is there in the chat because I will not be able to see the chat.
Susan and yeah, there are students
Yes, ma'am.
who help us.
Okay. Explanation of mathematics is limited to explaining the steps for solving the problem.
So far, people are disagreeing with it.
Disagreeing. Okay. If there is anybody who agree, please do come forward.
All responses are disagree right now.
Okay. So if anyone would like to unmute and speak, if it is not just explaining the steps of the problem, what is explanation? What exactly is explanation of mathematics if it is not just explaining the steps for solving the problem? Would anybody like to share?
In fact, I agree that it is still limited to explaining the steps, because otherwise they would tell us about where it could be applied and the application of the problem.
Okay. Yeah. So you are critiquing that right now in mathematics classroom, it is limited to the steps.
Yes.
But you think that it is beyond that and something more than that should be done for explanation, and perhaps it is application of mathematics.
Yes.
Okay. Any other idea besides application?
Lalin says partially agree. If he wants to explain, he can explain.
For example, ma'am, I got a question from a student. Okay. So they asked why we are learning binomial expansion, where it would be used. Okay.
Yeah.
So there is some vague answer from me. Like I told them in financial mathematics, this binomial expansion are used under the formulas, but I couldn't explain them properly that how practically we can use that.
Yeah. Yeah. So that there is a sort of, this break between the way mathematics, the abstract mathematics is done in the classroom. In fact, all of the mathematics is considered as abstract because it is, sort of idealized. So, and it's break from the connection with the real life, because up to primary level, yes, we are able to find the connections very easily with the daily life mathematics, but still it is not connected. But when we move to middle school and high school and senior higher secondary, it becomes more and more difficult to find examples where this kind of mathematics is used. But I want you to think a little bit more. Is it that, you are supposed to understand the problem, solve these problems, and then find an application? Is that the way the mathematics is generated? What is the genesis of mathematics? The genesis of mathematics is from situations itself. How you see the situation, your perspective of looking at the situation itself. And can that be the starting point for learning of mathematics? If you remember, in NCF 2005, they had introduced one idea, mathematization. Mathematization. What does this mathematization involve? It is essentially looking at a situation through the lens of mathematics. You're converting the real life into a mathematical form. You may be converting even an imaginary situation into a real life form. There are lots of things in mathematics which may not correspond exactly to things that are there in real life, but they are anyway very useful for you to know. And these are the things that provide motivation for students to learn mathematics. So why should we not include that in our curriculum and classroom teaching? Okay. So the second one, a student can become good in mathematics by practicing lot of similar problems of mathematics. Can people indicate their agreement or disagreement for this one? A student can become good in mathematics by practicing lot of similar problems of mathematics.
The participants are agreeing with it.
Okay.
Sunita is partly agreeing with it.
Okay. Anybody who disagrees?
Sam partly agrees with it.
Okay. Would anybody who partly agrees like to share?
Vaman disagrees.
Okay. Vaman, if you want to share. I mean, if it's
Hi,
good
ma'am.
to always know what
Hi.
is the
Yes.
the
I
different
would like
points.
to totally disagree with this, because I've seen this behavior in students, which is quite common these days, that the moment you give them, say suppose I'm giving them 3 problems, okay, so I solve one, I give them 3. The process becomes mechanical. That is never an aim of mathematics. We are not here to produce machines, okay.
Yes.
Rather, the aim is only to have that intuitive knowledge and to discover that there are several other ways to do one particular thing. But the moment we give them some solution, some hint, somewhere, that's all. That's the end of the thinking process of a child. So for me, I totally disagree with this, because at that particular moment, they may be doing well because they have all the sequence of the steps right in front of them, or rather just a flip of a page. But when you give them the same problem in any other day, they flunk. They cannot process anything. And right now, if you see, at least in my school, the place where I teach, the students, they have this phobia for math. They say like, sir, I don't understand when I should use which step, which formula,
Yes.
how do I come to that? And that is because of this second point, that we have been giving them so many problems, that because of solving so many problems, they are fed up of math. Nobody wants to look at math anymore. Given an option for math, they will always choose the other option.
Yeah, it's not
this
just
is the
being
reality.
fed up of the mathematics. Thank you. I mean, your points are very, very lucid. It's very much applicable to the way we are teaching mathematics. But I would just like to point this out, that it is not that they are fed up of doing mathematics. Not only that, but it is also they have stopped looking at mathematics. It's like, analogy I would draw is the recipe. You sort of have given them a recipe and they're using the same recipe again and again without understanding what they are creating.
Exactly.
So they need to own the mathematics. The mathematics has to be their own. And for that, they need to do the thinking. There is no thinking happening if they are just using the same formula and putting in the same numbers and just doing the calculation itself, because it's just calculation, which we can do with our calculators now.
Exactly.
Thinking process is absolutely not happening. So yes, practice is necessary, but solving 100 problems of same type, I don't think that really helps in understanding, developing
that doesn't
understanding.
Help. That doesn't help. In return, it increases the burden of a teacher, because then you have a lot many set to correct.
Yeah.
That's the only thing. The output is not up to the mark, and that's definitely what a teacher won't expect the output to be.
Yeah, thank you so much, Vaman sir. So next point that we have is mathematical ability is inborn and cannot change during life. We'll go a little faster on the next 2-3 months. We'll take these next 3 and then we will have a discussion on it.
The participants are disagreeing with it.
Okay. It's also because I discussed it a bit in the beginning. Okay, then
Sunita says, if only they would try.
Yeah. And let's see for number 4. Boys perform better in mathematics than girls.
Disagree.
Yeah, they disagree, but what happens is that they implicitly, these ideas are reflected more implicitly in behavior rather than explicitly in the talk. They may say that, it's not true, but in the way you behave, in the way, girls get chance to, get into mathematical careers which involve mathematics, or to even pursue degree in mathematics. That if you see that there is very less percentage of girls which are there in these careers. But if you see up to 10th level, up to 12th level, girls are performing much better. And for years we have heard this, that, in board, girls have performed better than boys and everything. We see that. But why we don't see girls in these lucrative careers in mathematics streams or physics streams? Even in IIT, they had to put in reservation for the girls. So why are we not seeing that? It is because a certain kind of implicit these kind of ideas which are present in our society and might be reflected in our behavior explicitly or implicitly. Then the fifth one, if a student makes a mistake in mathematics, a teacher should explain the steps of the problem slowly.
The participants are agreeing with it.
Okay. If anyone disagrees, then just let me know. Or if anyone who agrees also wants to explain why, that is also okay.
No teacher should try to tell again. So disagrees.
Okay.
Would you like to explain, Shelja?
If the teacher is just explaining the steps slowly, it's more like he is memorizing the thing to the student. The student, she can just give a hint or something, or maybe tell a different perspective, and student can try again the same sum.
It is again like what I said, it's like giving the recipe again. You're telling the steps of the recipe and you're not making the student think. There is a very nice video I have somewhere in my course, which is about, the student's mistake itself. The teacher just gives a small question on chits of paper on the blackboard, and students write it on a chits of paper. She collects it, and then she discusses the mistake that she likes the most. And when she is discussing that mistake, she first points out what all things that person has done correctly, so that the person gains confidence that this is this is correct. And then she asks the whole class to think about, what is wrong and why the person would have thought in that manner. So it's about a collective learning about, understanding that it is a mistake, and also trying to get into the other person's shoes of understanding why that mistake was made, and this kind of empathy, this kind of understanding about mistakes, can be useful not only for the teacher, but also for the students. So I would say that if a student makes a mistake in mathematics, the teacher really needs to diagnose what exactly is the conceptual gap. I just remember this incidents of one student who was, very good in doing calculation also, but one day, we said something like 2079. So primary student, and he wrote 2002 and then 3 zeros and then 79. So what exactly is the problem here? The student understands 2000 as a unit. The student understands 79 as a unit. But how to bring them together, how to compose this number, that is what the student doesn't know. Yes. Somebody was saying something? Yeah.
Concept of place value is not clear for that child.
Exactly. So that is the conceptual gap. As a teacher, you need to find out that the place value is not clear, and perhaps introduce the idea of abacus and use abacus for that child and address that mistake. So if you tell the step again of how to write it in proper place value, maybe it will not help so much. But if you explain the concept, it will help the student. Yeah, so let's move a little bit faster because I have lots of other things also to share with you. Yeah, the activities in mathematics provide fun and engagement for learning of mathematics, but do not help in learning concepts. Let's see what they are saying. Vinny, any response?
One response says disagree.
Okay.
Susan, please take up the YouTube because some people are messaging that YouTube, the responses are not taken up.
Ma'am, there is a little lag in the YouTube, so the
Okay,
responses are
okay.
coming late.
Yeah, it's okay. So disagree. Yeah, let us see why teachers think like that. We will discuss that in one of the sections of the PPT, and then we will go. Now we will go to next one, seventh one. ICT resources only provide distraction from learning mathematics. What do you think about that? Agree or disagree?
Disagree. Dhanashri says for younger kids agree, but for higher classes disagree. Even on YouTube it is disagree. Shelja says slightly agree to a little extent.
So one has to really actually know what kind of ICT resources they are talking about, because there is a plethora of ICT resources which are available. There are ICT resources which, they just provide these kind of repeated practice and might be good to some extent for student to master some sort of calculation. But there are also other kinds of ICT resources like GeoGebra that helps in visualizing mathematics. And that has been considered by a lot of teachers as well as students as being very, very helpful for learning mathematics, because it helps you to visualize. Yeah. The next point, situations or word problems should be introduced after teaching the procedure as it is application based. Situations or word problems should be introduced after teaching the procedure as it is application based.
One of the responses says actually no, but happens in real life, and Deepa disagrees. Others agree.
Susan, on the YouTube, it is one Jill, she has responded.
Ma'am, that is for the previous question.
Okay.
Okay.
Okay, so there is a lot of variety in this. There are some who are saying agree, some disagree. And I would just like to introduce this idea, mostly how the mathematics textbook was structured was, first you introduce the concept, then there will be some sort of introduction of algorithm or a formula, and then finally there will be word problems or situation-based problem. And although due to reform, a lot of these textbook at primary level has definitely changed, they haven't changed much in middle or secondary level. And the teaching is still in this manner. But if you see research, mathematics education research, you will find that, problem solving is a kind of, strategy which has been greatly vouched for supporting mathematical thinking. And this problem solving is not just solving word problems, the way that which formula to put, which operations to do, and so on and so forth. Problem solving involves you looking at the problem, making a model of it, maybe using some visuals, using some graphic, and then converting it into a mathematical representation and finding the answer. So this problem solving starts, it's for introducing the concept itself, you start with the problem, not at the end. And these are the ideas, which many of the, I would say, countries like Finland or Netherlands, they have found it to be very, very useful. And there is a lot of literature also, which is present in mathematics education research of starting with problem solving, introducing the ideas and concepts with problem solving. Okay. So I won't spend more time on this slide. I think we should move ahead. Yeah. So let's take a sort of break for this, watching this video. And this video is going to tell you a little bit about fixed and growth mindset. So we discussed whether, a mathematical ability is something which is, one is inborn or one develops it as one grows up. And this video talks about that itself.
Ruchi, is there sound in this video?
Sorry,
Is
there
there
is sound. I had shared the sound when I had started sharing. Just let me know if you can hear the sound.
Okay.
Huh? Yeah. Can you hear?
Fear is an obstacle to learning mathematics, but it is not the only one. Our mindset towards mathematics influences our experiences with it. Some people believe that all of us have certain abilities within us, and these are the only ones we will have throughout our lives. Some others believe that we can grow our abilities and skills as we learn more things and work harder. Carol Dweck, an educational researcher, says that people from the first category have a fixed mindset, and the people from the second category have a growth mindset. What is the difference between a fixed mindset and a growth mindset? A person with a fixed mindset sees a learner as a plastic plant with unchanging features. A person with a growth mindset, on the other hand, sees a learner as a real plant, capable of growing and changing in response to the environment. The mindset of both teachers and learners shape the teaching and learning process. Let's look at an example. A student with a fixed mindset comes across her first fraction. If she understands it easily, she will believe that she has the ability to excel in mathematics and will work towards it. If she doesn't, she could believe she isn't good at mathematics and might stop making an effort. This could happen at the first instance or at any time in the process of learning mathematics. But when a student with a growth mindset faces a challenge, she will direct her effort to overcome this challenge and learn because she believes that this can be done. Teachers also fall within these two categories. Teachers with fixed mindsets will see a student struggling with mathematics and decide that he or she doesn't have a natural ability to be good at the subject. So they won't focus on that student's learning. But teachers with a growth mindset will work on developing the student's mathematical abilities because they believe that this ability can be cultivated within every child. The mindset of teachers cannot be kept a secret. Through our interactions and our responses, our mindset becomes clear to our students. If we have a fixed mindset, children will also develop a fixed mindset. What then should we do? We should cultivate a growth mindset ourselves. The first step in doing this is to recognize the role hard work plays in learning. When a student does well, instead of saying, "Good job, you are very smart," say, "Good job, you clearly worked very hard." Guide the student to attribute their success to their hard work rather than their current ability. When a student works hard and yet does not do well, if you say, "Better luck next time," the focus is shifted from their hard work to their luck. A better response is to say, "That was a great effort. Now let's see how we can do better." We must consciously adopt a growth mindset ourselves and approach every student with the faith that with enough hard work and the right learning activities, the student will be able to enjoy mathematics.
Thank you. Thank you. Okay, so getting back to my presentation. Yeah, here. So I would like to hear some comments from you and also want you to reflect on this video. So think, can you reflect on how fixed or growth mindset has affected your own learning or your own teaching of mathematics? And where else have you encountered such mindset? Means beside your own self, where else have you seen this kind of fixed mindset or growth mindset? And what do you think you can do to address it? So let's take a minute to think about it. And I would love to hear some responses. If you want to unmute, or you can type it on chat itself.
Ma'am, may I? Sarita here.
Sure, sure. Please go ahead.
Ma'am, when I was a child, then at that time, I was having a fixed mindset that I want to clear my paper. But now as I'm a teacher, I need to, I'm moving towards a growth mindset.
Okay. In what ways are you moving towards growth mindset? How are you ensuring that it is growth mindset?
Ma'am, I'm trying to use different methods for a particular concept. So that each and every child will understand it properly.
Okay. Also, I mean, take a time to diagnose also, identify the conceptual gap so that you are able to address that. Yes. And also sometimes, the marks are not really a reflection of your complete understanding. Marks are very much dependent on the kind of questions that are asked in the test or in the exam. And sometimes, it may not be somebody who's feeling anxiety, somebody who has this math anxiety may not be able to perform well in exam, but may know the concept, and outside of the stressful situation, that person may be able to perform better. So one needs to consider that also. And therefore there is, if you see the assessment book by NCERT, they have also suggested a lot of different kinds of assessment, performance based assessment, rubric based assessment, so that you get a better sense of what student actually knows. Yeah. And also to create non-stressful situation for students. Would anybody else also would like to share anything?
Ma'am, one thing is, I feel phobia and fixed mindset are two different concepts, right? I mean,
yes.
For example, all through my school years, I did really well in maths. I used to understand things, but still I had fear. I used to cry that I will fail in the next class. And though I used to get like top marks and all, but I had that fear. And still now I have that phobia. I'm trying to overcome it because now that I am a teacher, I can. So I don't know how to get over that phobia. Like mindset is growth mindset, but phobia is there.
No, I think you need to recognize that once we have that phobia, that is, it's not that our mindset is completely fixed or is completely growth. So you may understand that it is possible, you may want to believe it, but somewhere in your subconscious, your previous experiences of, that stressful situation of the exam itself, that still, emotional response is still there, and there is an emotional memory of it, and therefore it might be triggered. But at the same time, if you are feeling phobia, somewhere in your subconscious, there is a little bit of fixed mindset there, which makes you feel that if I had this fear previous time, I will again go through this fear. I cannot overcome it. So the fixed mindset is in thinking that you cannot overcome this phobia. It is possible to overcome this phobia if you take efforts to think about it, why you have this, what can you do to overcome it, and take steps toward it. So gradually you will start feeling better. And let me tell you my own example. During school days, I really wanted to, be very good at public speaking. And I had such phobia that, when I used to go on the stage, I was not able to speak up. And I am right now an example that where I can now speak extempore, and I am able to speak publicly. So it's not that it will remain that if you think that I have this phobia and I will not be able to overcome it, you don't take steps toward it. You don't put yourself in a risky situation where you are required to do public speaking, you will not be able to overcome. So since you have got into teaching of mathematics, I'm sure at some point of time you will be able to overcome it because you are fighting that feeling. I hope
Dhanashri, yes.
Yeah.
Yes.
And the next reply is by Dhanashri. She says, if the child is making mistake, I need to encourage him or her to redo the question. As a teacher, I will guide or help her to solve the problem.
Okay. Yeah, this must be in response to the previous slide that we were showing about the students' mistakes itself. I think it's a good strategy to ask the student to solve it again and to rethink. Also, there are a lot of ways in mathematics also through which you can check your answer and identify where the mistakes are, especially at the lower level, primary level. At least one can do that. And one can teach those strategies also. One can also, as a teacher, you also need to identify where the problem lies. Is the problem there in understanding the question and writing in a mathematical form? Many times the translation from a question to the first statement of the problem, there itself the problem lies. Sometimes the problem lies in the calculation. Sometimes the problem lies in some sort of which we call a silly mistake, because you are stressed, your working memory is not working that well, and you have made some sort of a silly mistake there. So what kind of mistake it is, you need to identify that first and address it accordingly. Yeah. So I hope it addresses your issue.
Ma'am, Sunita has replied, I have the fixed mindset all around me. It is okay to say I hate maths, but nobody hears one saying I hate English. My tuition kid's mom feels it is okay to tell me she is not good in maths.
Yeah. Yes, that is very much. So we see that, people very proudly, they say that, I don't have the mathematical mindset. I can't do mathematics. And when you, do it so proudly in front of children, they also sort of imbibe it that, it's okay to say something like that. One cannot learn it. And we may say, I'm not good at dance. I'm not good at music, which indicates, somewhere that you have this idea that these things are inborn and one cannot develop it. So it's there in our language, it's there all around us in the society itself, and it is important as a teacher to recognize that, because your own language in the classroom also might be having it in one way or another, and it is not something which you will understand without reflecting on the language that you are using, without reflecting on the society and the ideas in which you yourself are situated. So I think we really need to reflect on whether we as a society, which kinds of ideas are there, whether they are promoting fixed mindset or growth mindset. Okay, so let's move further. Yeah. So now we move to reflection on tasks for teaching mathematics. So here we engage with the mathematics itself. Suppose this is the problem that you have given to the students, written at the top. Raju brought vegetables worth ₹85 from a vegetable seller, and he has only ₹100. How much money should he expect back? It's a very simple primary level problem. So how do you think one should solve it? An expected solution is given. How do you think students will solve it?
I would just tell the student that just think you are at a store, you give 100 rupees, tell me how much they will give back. So they may count on their finger, or they may think whatever they will do, but they have to give the answer.
Yes.
And then can ask them, how did you do?
Yeah, but now I want you to be more specific. They may think do it by hand or do it by this. But what is it, when we give this kind of problem in our classroom, we expect this kind of solution, that student may write 100 and then minus 85 in a vertical subtraction form, and then they have to use borrowing, right? Isn't that what we expect them to do? But are there any other methods?
No.
Yeah. Yeah.
We shouldn't be expecting that. Huh? Many teachers must be doing, but we shouldn't be expecting that.
What is the other method that you can use to solve this?
One simple is mental maths. Then
How? Tell me the how. How will you do that? The same way that you will ask the student.
so they may first, okay, if I am, then first I may try 100 minus 80 because that's more easier in the tens
Okay.
count.
Okay.
So 20
Yeah.
remains, and then I will say, okay, remove more 5 rupees
Yeah.
because 85. Then how much remains?
Yeah. So you again used mental math because it's, you know, and you started with 100 and subtracted 80 because it was easier. Yeah.
Maybe I'm doing because now I'm grown up, but yeah, students may not understand what.
Okay. Any other way? Have you ever been to the vegetable market and actually done this?
Yeah, Ruchi, I was just thinking, before we calculate the bhaias, they calculate fast and they.
How? Have you seen their strategy?
Yeah, they have this whole number or subtraction only, and then they see.
How do they do it? Just, I mean, I want to know the exact strategy used by them.
Ma'am, this is in reference to the previous question. Anu says to count from 85 to 100. So any other method. Ashu also says 85, 90, 100, they can count as such.
Okay. 85 to 90 and 90 to 100.
Actually, going backwards is also a good way, that 100 and 90.
Okay, so they were, I am not sure if they will call it going backwards. They might say going upwards or going forwards, towards 100. Okay, so it is possible. See, if you see that as a number line, and from 85, how will you reach 100? You will take one jump of 5, and then you will take one jump of 10. So that means 5 and 10, 15. And this is if you have been to these vegetable sellers and watch them closely how they do it. That is what they do.
Yeah, they say that 5 rupiya, the 5 rupiya 90, फिर ये 10 rupiya 100. They do that way.
Yes.
So
Yes.
they
So they are actually using addition here.
Oh.
Yeah, exactly. So do you think this is a valid strategy?
Yes, yes.
Consider if the student is doing this in your classroom, will you accept it? She's using addition to find this, that you have to get 15.
We have taught them subtraction. If something is to be removed, then subtraction. If something is to be added, then addition. This is what
we have to change our mindset, I think. If a student comes up with this, it's so much easier, no? And addition is always easier than subtraction, right?
Yes, it is. And it has been confirmed through research also, that this kind of problem, it is much more intuitive to do addition, to find it by addition rather than by subtraction. The problem is that we in our mathematics classroom do not accept that as a strategy. But why? Don't we know that addition and subtraction are inverse operation? They are inverse operation. So I mean, if the student understand that, if you go in the opposite way, then also you are doing subtraction. Doesn't that satisfy?
And that's the problem with, I would say, Indian education. If I see IB curriculum, IGCSE curriculum, I had a student, I used to just give me answers so fast. And used to say in exam, I said, where are the steps? He said, no, in our school, we just write the answers. I'm like, very good. You don't need what.
No, I would again comment on that. See, it is not about just writing the answer. If you just write I think it is okay for students to do it sometimes, but explaining your thinking and being able to express your thinking in form of a mathematical representation is something which is very important and is the strength of our education system. Indian education system it is focused a lot that students are able to express mathematically. Steps kaise likhne us pe focus kiya. I don't think we should remove that focus completely, but we should help the students to be able to express what they are thinking through those mathematical representation. That is where the focus needs to shift. And the other thing that you said, that coming up with the answer fast, that is also in some way reflective of a fixed mindset, because there are students who take time. So being fast and being slow is not an indication of mathematical ability. sometimes, you know, the answer is to get to the goal, whether you reach the goal directly or whether you go through different ways, meandering ways, and reach that goal. Ultimately, you are able to get that. And sometimes when you meander, when you go through separate roads, you learn more new things, right? You know, even in our real life. So why not allow that opportunity to our kids? No, why to insist on doing mathematics fast? It is, we insist on it because the entrance exam require it. And for entrance exam, we start teaching them right at the KG itself to do mathematics first. But after the entrance exam, if you see the mathematics that the real mathematics that is required, people take, you know, several days, months, years to develop mathematics, real mathematics. It takes time. And students do not understand that creating something takes time. So I think we need to also include that in our mathematics education. Okay.
Yes, very nice.
Yeah.
Okay, so you please explain that. So you told that addition would be a greater way, but then while solving in the exam, we have to do the subtraction. Then
so what you, I mean, it is required. I think the examination, you as a teacher also need to change. And if it is done through addition, but is the child is able to represent it visually, or in express it mathematically in some form, like that 85, if the child has written 85 plus 15 is equal to 100. You know, aage jaake in algebra, we anyway teach them, right? That it can be written in the form that 85 equals to 100 minus 50, or 100 minus 85 equals to 50. It can all be written in that form. Ultimately, we do that. So if the child is writing 85 plus 15 equals to 100, I think we need to acknowledge as teachers that the child understand that the difference between 85 and 100 is 15, and we should be giving marks. That is what my opinion is.
Thank you.
Yeah, and I think we should allow this kind of diversity in our classrooms. Okay, yeah, let's get to the next one. Just the time. Yeah, so this one is a slightly more complicated one, but let us see how we get around it. So try this calculation first. 34 multiplied by half, 34 divided by 2, and 34 divided by half. Okay, you can try this as a calculation, write down the steps, and then you see here using the context A, B, C, these are all mixed. Okay, so which of these three problems correspond to this calculation? So for example, the A here, 3/4 of a glass was full of juice and the two brothers divided into 2. So this statement corresponds to which calculation? The A with 3/4 multiplied by half, B which is 3/4 divided by 2, or C 3/4 divided by half. Which one does it correspond to? Similarly for B, similarly for C.
B.
Yeah, right now be quiet and take 1 minute to do this and post your response in the chat, and then we will discuss. You'll be quiet for 1 minute. Let's give everyone time to engage with it.
B. A and B.
Shailja is saying A is corresponding to the B and 2 is corresponding
A and B.
Ma'am, most of the answers are B.
Okay. context A to B, context B to C. Sunita, context C to A. Okay. Yeah. Anyone would like to unmute and speak and explain which one corresponds to which one? Sunita, would you like to do that?
Yeah, as usual, in maths class, I was in a hurry to give my answer. So it's
Get into a growth mindset and engage with it. Yeah.
Yeah, so it's A to B because
explain why. Explain why.
The two brothers divided it into two, so it's clearly 3/4 divide by 2.
Okay, great. That is correct. Next one.
3/4 kg. How many half kg packs can be made with it? It is C because you divide by half, right? That is a thing of division, no? How many? Basically, you divide by that to find out how many you can. How many?
Does everyone agree with it?
Ma'am, the first one could also be A, I feel. The A one could also be A.
The A can also be A. Okay, why?
Because it is dividing it into half, so it is multiplying it by 1 by 2. So the division goes.
Yeah, so are you saying that the sugar in the box one can also be A because you are dividing it into halves?
No, ma'am, the glass of juice.
The glass of juice can also be A because you are dividing it into 2. Okay, okay. We will come to that. Thanks for that response. So I think I'll address this because we have limited time. So what the student has said, the A 3/4 of a glass was full of juice and two brothers divided into 2. Yes, it can be expressed both by A as well as B. You know, dividing by 2 and multiplying by half is the same thing actually, right? But the way it is written, it corresponds more closely to B, that 3/4 divided by 2. Also because it was divided amongst the two brothers, you know. So multiplying by half, when you are saying, it is generally taking half of something. In natural language, when you convert this multiplying by half, it is generally said in the way that taking half of something. So what does it correspond to? The C1. So there was a 3/4 bag of rice and Stella took half of it. And to make it slightly more complicated, I added that extra line there. Okay. So yes, the A1 corresponds to the C. There was 3/4 bag of rice and weighing, I think that got deleted somewhere. And Stella took half of it. So that corresponds to A. And Sunita, you were absolutely right. That 3/4 kg sugar is in the box, and how many half kg kg pack can be made with it? This one corresponds to C, that is 3/4 divided by half. Now, but most people find it most counterintuitive to understand the B1 because they represent that also by divided by 2, because they think something which is, you know, is to be made into half is something which can be divided into 2. So this connection between the mathematical representation and the statement, it is a very important connection that needs to be made and which students find very difficult. And what can we do to help this making this connection? We can use the visual representations. So let me show you how. So if this visual representation, what do you think it corresponds to? क्या दिख रहा है आपको first वाले figure में? First figure में, in this one, what do you see? What?
4 compartments are made and 3 are shaded blue.
So how would you call that into a mathematical number representation? Fraction representation में आप कैसे कहेंगे इसको?
3 by 4. That is
3 by 4. And now I have put this black line here. So what have you done?
Half plus 1/4.
Half plus 1/4. Would you represent that as half plus 1/4? Where so this is, what are you calling as half?
Means what exactly we have to do after that line?
So this line has been made. Okay. So what do you call this action of making this line? What are you exactly doing? So right now you see 3/4, but now
It's half of 3/4.
Yeah,
you're taking half of
3/4.
3/4. That is correct. You are making half of 3/4. So which mathematical representation does it correspond to? Does it correspond to A, 3/4 multiplied by half? Does it correspond to 3/4 divided by 2? Does it correspond to 3/4 divided by half?
C.
A.
C.
C.
Divided.
A, C. There are two different responses. Any other responses?
A.
B.
Okay,
No,
we
it
have got
could
all
be
the...
B, no, because 3/4
B.
is divided by 2.
Okay. So you have given your justification. Would anybody else also give?
Half of is half multiplied by. Simple.
Okay. Yeah. So again, because these two things, A and B, are the same essentially. Dividing by 2 can also be written as multiplied by half. This visual right now is representing both A as well as B. So here 3/4 is being divided by 2. And now if you have to say how much this portion is, I hope you can see my mouse. Can you see my mouse?
Yes.
Yes.
If you have to say how much this portion is, how will you do that? So for that, you will have to, oh, I am so sorry. Yeah. So for that, you will have to divide all these 1/4 into, you have to make further half of it, and now you will be able to say how much of this portion is. Can you say how much is it?
3 by 8.
It is 3/8. And now can you check it through your calculation? 3/4 multiplied by half, 3/4 divided by 2 is corresponds to 3/8. Right? Now let's see this one, the second one. Okay. So here when we are saying 3/4 divided by half, so what does it mean in terms of action? What does it mean in terms of the statement? So B statement corresponds to it. When we are saying divided by half, we essentially are saying how many halves are inside 3/4. And that if we have to calculate that we know at least one full half is there, right? But can we have second half here? No, because it's only half of it is there. So let's put one more half and see. So it is going beyond 3/4. So what do? We make other. So how many halves are there in 3/4? There is one full half and one half of half is there. So a total of 1.5 halves are there in 3/4, which is equal to 3/2. And again, you can check it by doing this calculation. So when we are saying dividing by half, we are essentially saying how many halves can you see in 3/4. Okay. So this is the kind of idea which we have not been taught in our school, but is very useful in understanding fractions, in understanding operations of fraction, because they have never made meaning to us. One of the person had said that we are finding it very difficult binomial expression to find it correspondence in real life. This is also one of those cases. Fractions maybe. I mean, it's very difficult to find the real life correspondence, but if you understand how it is represented in these forms, it will make it easier. If you understand how it is represented in situations, it will make it easier for you, as well as your students. Okay.
But then sometimes it happens, we try to teach all this and then they are like, why so much of time waste? At the end, answer should we have to write 3 upon 2. We have to cover portion and everything.
Yeah, that all is there. But, that is where the problem lies. But if you give them these kind of problems, and these are the kind of situations they will face in real life, you know.
Yeah, and actually, in mathematics textbooks also, I have seen that mostly there are less of word problems.
Yes.
There are all these kind of sums, like 3/4 into half, or 3/4 divided by 2. So that is very mechanical. They know how to do
And
it. But
then
when it
you
comes
are
to word
learning
problems,
only something which can be done by calculator. And going forward, the way the world is going, I mean, we
Yeah.
would not need to do these kind of calculations, but we would. This is something that a human brain needs to do, you know, converting
Exactly.
that situation into a mathematical form. This visual representation is something that a human needs to do, right? So these kind of reasoning, because it involves reasoning, and reasoning is what we need to focus in our schools. Another example, suppose you have to calculate this 38 plus 39 plus 40 plus 41 plus 42. So which approach do you think out of the two that is visual, that is there, which approach do you think is better? The first approach or the second approach? किसको आप ज़्यादा marks दोगे?
Both are correct answers.
Second one.
Both are correct. I know, but which one do you appreciate more?
Second one.
Yeah, second one. That
Second one, which
appreciation.
is this one.
Yeah.
So I have given that name, I think, ciphering strategy and tinkering strategy. You are suggesting tinkering strategy, right?
Yes, ma'am.
Okay. Why, please, can you explain?
Because it's easier to make a group of tens, like 38 and 42. So 30
So
and
if it is easier, then why would you appreciate that more? When
I won't appreciate that method.
Which method?
The tinkering one, I won't appreciate.
You appreciate this one?
Yeah.
Okay. The ciphering method. Okay. Anybody else?
Ma'am, may I?
Yeah, please go ahead.
Ma'am, the tinkering method, I would appreciate the tinkering method because the student has found a relationship between the numbers given. So they have found a middle value and found the relation that the next values, that is 1 before 40 and 1 after 40 would give us some similar values, and the same 2 before 40 and 2 before after 40 would give us some similar values.
Yeah.
So more thinking is involved in this type of logic.
There is a reasoning involved. That is what I see. We tend to think that this is mathematics. What this first child is doing, this is mathematics, where the child is aligning the numbers in vertical form and finding out the numbers and painfully finding out the total. That is what is mathematics. But that is not at all mathematics. It is some mechanical calculation. This, the second child, what she is doing, that is mathematics. You know, to be able to see pattern in numbers, to be able to see the relationship between numbers, to be able to become flexible with numbers, so that you are able to see visually. If not in this way, all you have to do is the 41, 1 you take to this side to 39, it will become 40. 2 you take to 38, it will become 40. And you can visually, you see that there are 5 40s are there. 5 multiplied by 40, 200. That can be even yet more efficient method than this one. So it is about seeing efficiency. जो आपने easy word use किया था ना, उसके बजाय efficiency. Here efficiency is visible, and also you can see students reasoning and relationship between numbers, and that is what needs to be appreciated in the classroom, and not this one. I'll just give you orally one problem. So for example, 464 plus 464 plus 464 plus 464 upon 4. So I have asked you to add 464 4 times and then divide by 4. How will you go about doing it? Would you add all 464s 4 times and then divide it by long division of 4?
Can multiply first.
464 adding 4 times is same as multiplying 464 by 4.
Yes.
So then you have 4 in the numerator and 4 in the denominator, so which you can cancel out, and that gives you 464.
Yeah, so you don't even need to say these steps. I mean, you instantaneously, as soon as I say that it is 464 4 times, that it can be converted into multiply by 4, and upon 4 means that will get cut, and you don't need to add it. So that is the reasoning that we need to teach our students. So this is the reflection on task that I had wanted all of us to do. The next is reflection on pedagogy itself. So I have given here 2 teachers strategy for teaching geometry in the classroom. You can read it. I will also read it aloud, and then think which pedagogy would you prefer and why. You have to also explain why. Okay. So P1 is teacher 1 is teaching lines and angles to 7th grade. She solves a problem on the board. She then tells students to remember that angles formed by 2 intersecting lines will have vertically opposite angles, which will always be equal. 2 parallel lines will have corresponding angles, which will always be equal. Then she asked the students to solve 6 problems from the textbook, which are very similar to the one done on the board. Now let's see what teacher 2 is doing. The teacher 2 is asking students to use 2 rulers at 90 degrees and then move one of the rulers to see how one of the angles between the rulers narrow down while the other angle increase in size. She asked the students to move these rulers around so that they vary the angle at which these 2 rulers are intersecting. She then asked them to share observation about what remains constant and what is changing, and what properties of angles will remain constant in different situations. So, which pedagogy would you prefer? The teacher 1 pedagogy or teacher 2 pedagogy? You can respond on chat or by
teacher 2.
Why?
Because teacher 1 mentions that angles formed by 2 intersecting lines will have vertically opposite angles, which will always be equal, but not necessary.
Not necessary. Yeah, go ahead.
Ma'am, teacher 2 is just telling them verbally, but teacher 2 is making the students to realize and do them by their own, so that they will remember, I mean, they will understand the concept clearly.
Yeah. Yeah. So in doing this, changing the rulers, they will see that one angle is narrowing, then other one is increasing. So there is some sort of a compensation happening, and through their observation, maybe they will be able to identify that there is some pattern in that. And when the same thing, I think I was not able to write that include that in this scenario here. But what happens is, after this, she uses GeoGebra to do the same thing there itself. So in that, the student can see that, as one angle is increasing, these 2 angles are remaining same, and the other vertically opposite angles are always remaining same. And also that, they can perhaps, the teacher can ask them to find out the sum of the angles and see different things. So here, these truths of mathematics, they are being derived from observation. And although we know that mathematics is not an inductive, it's not made through an inductive process, this inductive process, when done in the classroom, definitely helps students in understanding the mathematics more deeply. We know that geometry, ultimately, we have to arrive at the deductive proof. And, by moving these 2 rulers or doing this in GeoGebra, it is not considered as proof. But it helps the student to understand these geometrical ideas much better. And that is what needs to be done in the classroom than to directly shift to the proof itself.
So, ma'am, the respondents agree. They are saying that the teacher 2 would help in inductive thinking, foster self-learning, learning by doing, and allow analysis and reasoning.
Yeah. Okay. So there are some clicks resources. You can go on this website, https://clicksoer.tis.edu. And we have several of these ICT-based resources There is in geometric reasoning, there is a police squad game, there is a ratio pattern tool in proportional reasoning. There is an exercise of computing phone tariffs using graphs and GeoGebra in the linear equations module that we have. And I have also given example of two other clicks resources which we have found to be very, very useful. These are FET tools by University of Colorado and Mathigon also. If you Google them, FET and Mathigon, you will be able to find. I'll see if I can show you some of these resources. At what time should I end, Vinny? Can you give me an idea?
Yeah, it's already 5:30, so you can take 5 minutes more.
5 more minutes. Okay, so I'll just show you that website. And then I will show you the kind of courses that we have. Yeah, just one sec. Okay, so these are the other resources in the classroom that I wanted to talk about, but we don't have time now. There are different situations and context of mathematization. There are concrete and ICT resources. Student mistakes we have discussed. Languages used. Activities and artifacts from students' lives. Classroom walls. School buildings. And textbooks other than the ones prescribed by the I think I had that. I don't.
The fastest way to grow is to ride the trend of the future.
I thought I had kept it open. It seems. Okay, so I think what we can do is we can share that link with everyone, clicksoer.test.edu, and they can go at a later point and see those resources, because it will take some time to look. Yeah.
You can put up the link on the chat so everyone can access it.
Yeah, I'll just put that. If there is time at the end, maybe I can show you that, because I wanted to also show you the kind of courses that we have at our center, where we try to develop this reflective teaching with ICT. And the rationale for developing these courses was the teachers have very limited TPD opportunities, and they are not available in multiple Indian languages. So we have these courses in Hindi also and English also. And now we are tinkering with bilingual courses where both Hindi and English text are given side by side for the teachers. Then we know that the teaching environment is quite challenging, and to develop quality teaching, one needs very quality open educational resources which are free to use and free to share, free to adapt for using it in the classroom, and so that teacher can play the role of the designer also. And lastly, we know that teachers have been working in isolation in their classroom, and we wanted to develop communities of practice of teachers, where teachers can not only share their experience of teaching, but they can build on their knowledge of teaching by talking to each other, reflecting on their practices with their peers, reflecting with experts and other teacher educators. And in some way, these workshop series conducted by St. Xavier Institute, by TIS, I think they are contributing towards building these communities of practice. So in these courses, these are the sort of our key focus points. We try to develop these teacher learning communities and connect the subject experts and higher education institutes, make local knowledge visible, and we provide these certificate courses in blended mode. That we have these workshops. We even used to have face-to-face workshops before COVID times, and now we have online workshops, as well as teachers do these online courses in order to develop their reflective practice. And we have a lot of practice-based assignments here that the teachers have to do. So it is not just reading and discussing. You have to actually also try it out in your classroom and reflect in it in the community of practice. So we have several, communities which we have built on Telegram, and teachers regularly discuss what they are doing in the classroom, what problems they are facing, what is their learning in those Telegram communities itself. So our pedagogical pillars are peer discussion, learning from the mistakes itself, relevant and authentic learning, and value-based practices. We have done several field trials before we developed these courses, and now it has been, used in many states of India exactly, and we have in fact done in more than I think 500 schools in the states of Telangana, Chhattisgarh, Rajasthan, and Mizoram. And now we are extending ourselves to other geographies and even beyond India, like Tanzania, Nigeria, and Bhutan. They have also done a few of the courses. This is our model of working. Like the teacher has to, do an online course, have the face-to-face workshop with the test faculty, and in the schools, they are working with the students in the computer lab. They have some sort of a field support provided to them, and they have these community of practice on the Telegram where they are interacting with each other and also with the subject experts. Who can take this course? If you can see here, the blue box, all practicing and middle school and high school teachers can take it if they have an ICT lab, and you have the flexibility of doing 1 to 2 courses, and you can complete anytime within 5 years, and you need to earn at least 17 credits. All this can be explained again, whenever these courses are available in an open form. Okay, and if you go to the TISS website, you'll be able to see which courses are available. Now, this is an example of, communities of learning or practice on Telegram. So you can see how much teachers have shared, what are the different things that they are sharing, mathematical problems, concept maps, what they are doing in the classroom, the photos of their ICT labs. All these things are being shared in the communities. These are the different courses which are available. The compulsory course in this RTICT certificate program is Introduction to ICT in Education, which is for 12 weeks, Action Research. Then subject-specific courses include, which are optional. You have to take one of them. English language teaching, reflective maths teaching, interactive science teaching. And then there are electives. You can select 3-4 courses from the next basket of courses, which involves courses like media in classroom, hands-on learning through toy making, and other courses. Yeah. So the reflective mathematics teaching course, the course objective is developing an understanding of core ideas of mathematics and its processes, as well as its interconnection within and across mathematical domains. Also, to understand the value of engaging with student thinking and the role of assessment in informing teaching, and also to be able to meaningfully use, evaluate, and curate ICT-based teaching learning resources for mathematics learning. So we want teachers to understand the process of becoming reflective practitioners, the role of technology in becoming this reflective practitioner. We have this video, and I'll share the video in a minute. But so there are 3 courses for mathematics. The first one is geometric reasoning, which involves, the first unit is on student learning itself. The second unit is based on the geometric learning reasoning module that we have created for the student. You have to understand that, implement that in the classroom. And the third unit is understanding the key ideas of teaching mathematics, which involve problem solving as well as generalization. The SO2B course is based on proportional reasoning theme. Here the unit 1 is on understanding the resources for teaching. The second is based on the proportional reasoning module that we have developed. And third is engaging teachers in collaborative lesson planning. Then we have SO2C course also, which is in algebraic thinking. Here the first unit is assessment in mathematics. And the second one is based on the student module of understanding linear equations. that we have developed in Clix. And Unit 3 is on collaborative design and analysis of assessment. So I'll just show this video and that would be the end. Okay. Yeah. Sorry, there is an ad.
Is the Canada PR on your wish list? Canada is looking forward to welcome over 1 million immigrants.
Hi, my name is Ruchi Kumar. Welcome to this course on reflective mathematics teaching. I'm one of the designers of the course. In this video, we are going to talk about what reflective mathematics teaching is all about. What is reflective thinking? Reflective thinking is thinking carefully and deeply about the pedagogy that we employ to teach mathematics. As teachers, we reflect all the time. We reflect when we are wondering whether the method that we are using is helping students learn. We reflect when we are discussing a student's error and what students are finding difficult with our fellow teachers. We reflect when we are selecting a certain task or a problem from the textbook to teach a certain concept, and we also reflect when we are making a lesson plan based on what students already know. In doing all these activities, we are trying our best to reach out to our students. Let's begin with the problem that all teachers face. Here's what a teacher from a Sambalpur school from Chhattisgarh has to say about integrating ideas from workshops into teaching.
बीच बीच में तो ऐसे प्रशिक्षण होते रहता है, लेकिन ऐसा प्रशिक्षण से कोई ज़्यादा भी अपने दिनचर्या में हम लोग बदलाव नहीं ला सकते। प्रशिक्षण में तो सब बहुत कुछ मिलता है सीखने को, लेकिन जितना प्रशिक्षण में कर क्या रहते हैं वो सबको हमको एक तरफ रखना पड़ता है, और हमारे ध्यान में ज़्यादा बच्चे और सिलेबस का जो प्रेशर रहता है, इस कारण से प्रशिक्षण का ज़्यादा महत्व नहीं हो पाता फील्ड में.
So this course will help us to handle the challenges that we all face in teaching. It will also help us to put into practice what we learn in in-service teacher training through sharing and collaboration. So the pedagogy of this course is practice-based. It is based on the interactions that we have in our classrooms. We will look at the concrete examples of students' work and the interesting questions posed to the students. We will examine unusual and unexpected solutions offered by the students. We will also see how an everyday context can be used to teach a mathematical concept. We will reflect on these experiences and relate them to the theories of teaching and learning. This approach demands that we take a conscious and critical perspective of all that we do in the classroom. Another important component of this course is online collaboration. To ensure that our learning is rooted in ground realities, we will share our classroom experiences online with teacher educators and peers through applications like Telegram. This will help us to create a professional learning community made up of teachers, teacher educators, and academic experts. Participating in this community will help us to enhance our knowledge. It will also help us to handle the challenges that we face in teaching. It will further help us to find new and innovative ways of teaching and facilitating learning. After this course is completed, the community of practice will continue to explore, adapt, share, and critically reflect on the innovative teaching learning material. One of the major developments in the world of innovative education is the use of ICT-based teaching learning material. As part of this course, we are going to use, evaluate, and create ICT-based teaching learning material for teaching important mathematical concepts. We are also going to see how these ICT-based teaching learning material can address the learning challenges faced by the students. At the heart of all this is the recognition of the crucial role that teachers play in this world of education and learning. Doctors continuously update themselves about the new drugs in the market to provide effective treatment to their patients. Architects know the latest material that is available for building.
Ruchi?
Similarly, as teachers, we need to continuously evaluate the effectiveness of our practices.
Yeah, we don't have, we have already crossed our time.
Okay.
So can you please wind up?
Yeah, so I think that's all. That was the last thing that I wanted to say. This is the school synergy sessions. I will just share the link with you on the chat, and you can continue, ma'am.
Yeah. Susan, I would request you to share the research results of our last action research, what we did. So we have a small research that we have conducted on parental involvement in mathematics education. So very quickly, we will present the results.
Sure.
Ma'am, am I audible?
Yes, yes.
Okay. So good evening, everyone. Different studies reveal an association between parental involvement and academic achievement. Parental involvement refers to the situation where parents are directly involved in the education of their children. However, parental involvement has too many different dimensions, such as perception of support, organization, interest in educational process, etc. So researchers distinguish two main types of parental involvement. The first one concentrates on what a parent can do at home in order to strengthen their own children's education. And the second one on their involvement with activities organized at schools, such as meeting with teachers, school events, and parental federation. So last time we conducted a small study titled Parental Involvement in Mathematics Learning and received 175 responses. Thank you for that. And let's glance at some of the questions and responses from the survey. When stated that parents do not consider themselves competent in mathematics, 6.9% voted always, 36.6% voted frequently, 53.1% voted sometimes, and 3% voted never. When asked if it is impossible to get help from parents for mathematics learning, a majority of 81% generally disagree and 18% generally agree. I do not find it necessary to involve parents in mathematics teaching learning. 82% generally disagree with this statement, while 15% agree and 2.3% strongly agree with it. When asked if parents have their own method of doing mathematics that confuses the students, 61% agree that it is confusing for students, while 38.3% disagree. Parents help the students in their assignment and homework. 17.7% voted always, 32.6% voted frequently, 48.6% voted sometimes, and 1.1% voted never. When asked if parents are told that their involvement in mathematics for students' achievement is important, 88% voted yes, while 13.1% noted no. Parents have a critical role to play for understanding mathematical concepts. A majority of 78% agree with this statement. Parents' own anxieties may affect the students' mathematical learning. 22.9% strongly agree with this, along with 61.7% in agreement, making it a majority of 85% in agreement with this statement. Similarly, parents transfer their own mathematics phobia to the students. 69.2% agree, while 30.9% disagree. Parents are a hindrance rather than help in mathematics learning. 30.9% of our teacher participants agree with this statement, while 69% disagree. When asked whether parents only question the teachers about the students' performance, 52% of our teacher participants say always, 45% say sometimes, leaving only 2.9% who said parents never question the teachers. Parents cause negative effects rather than positive effect on mathematics learning. 65% disagree with this statement. Parents find tuitions and coaching classes as convenient option for students' mathematics learning. An unmatched majority of 93% participants generally agree with this statement. Homework can be used for increasing the parental involvement in mathematics. 67.4% agree with this strategy to increase parent involvement. Parents consider it okay. So we have many studies that all over the globe done on positive effects of parent involvement in their children's educations, achievements, and motivation. So the question arises, like how exactly as teachers we could increase this parent involvement? So agreeing to what the participants had noted, homework could help in increasing parent involvement. But the type of homework we give and the type of involvement parents have in the process matters. So for example, social, casual, and spontaneous maths allows for more logical, analytical thinking. So the problems that are given for assignment need to be of this kind. And it is important for the parents to make maths fun, so intellectually stimulating and an experience without stress. So this provides the children with a security and a good math self-concept. And everyday hands-on and playful activities that contain maths are ideal for this mathematical thinking that needs to be developed in students. And the second part is it is vital to keep parents informed and encourage a two-way dialogue. So communicating the information is important. And here are some of the strategies like holding workshops, having parents in the classroom, meet and greet discussions, displays, exhibitions, etc. And for the hard to reach parents, you can always have social media that can work wonders as it breaks down barriers and keeps them in the loop. So in all, like the African proverb, it takes a village to raise a child, and parents and teachers in collaboration can help create a mathematical mind. So thank you.
Thank you, Susan, for presenting the research, very well presented. And I would now request our manager, Father Blaise D'Souza. Father, do you want to say something before we end this meeting? Father Blaise?
Yes.
Yes, Father.
Well, as I always say, I am a non-mathematician in a mathematical context of your webinar. And yet, I would like to say that I would like to see mathematics more related to reality. That's why I like the word action reflection. These are two sides of the coin of mathematics. And the mathematical reflection must lead us to relate to the field, to relate to reality, to relate to help us to bring about social transformation. I think that is an important aspect of mathematics. It's not really a study in an abstract manner of figures and algebraic equations and formulae or geometry in the air, but we are in a world which is in need of social transformation. And the more people are able to bring about their mathematical reflection into making a critique of reality, of the social situation in which we find ourselves, it will help us to bring about social transformation. It will help us to bring about the equity and justice in the world in which we live today. Otherwise, you have populations that are very poor and small number of people who own a large part of the wealth in the world or in the nation, and others are not aware of this inequitous distribution. I think mathematics must help us to bring about the distribution of social justice in the world in which we live. I don't know whether Dr. Ruchi Kumar could in a way respond to what I have said.
I would absolutely agree with you. In fact, mathematics for social justice is definitely required, and we should include these kind of problems in our curriculum also. If you see the NCERT textbook, there are, there is a very nice question, and I think fourth standard, where the students have been asked to discuss, the income disparity between female and male workers, construction workers. So there are ways that we can address social justice by including such kind of things in the classroom. Data and understanding data, analyzing data, I think that is very much required. I totally agree with you.
I would just like to give a little example of in a rural setup where often mathematics is difficult for as it is taught. And I would send them out and say, now go out into the village and see how many lampposts are there in the village, light. And they go around and count. And then I ask them, where are these lampposts? Huh? And it will turn out that the lampposts are in the richer part of the village. And the greater part of the village is in darkness. So lampposts are there. And you can count them, but they are not for the benefit of everybody. I think that is where they will learn to perhaps make this critique, this social analysis, and say that if light is important, it is important for everyone and not for a certain group of people that are there in a village. Okay. So.
Thank you, Father. Thank you. I'll invite Olisa to deliver the vote of thanks. Olisa.
Yes, ma'am. Good evening to one and all. It gives me immense pleasure to propose a vote of thanks on behalf of St. Xavier's Institute of Education to all the dignitaries present here. This webinar made us all reflect upon many things which gave us an idea about how to master our mind to excel at mathematics by using various strategies and solutions which will empower rational thinking among us. A special thanks to our resource person, an amazing personality, Ms. Ruchi Kumar, who shared her precious tactics on how we can boost our competencies through reflective teaching. Your lookout on mathematics will boost mathematics learning in all numerous ways to all the trainee teachers, school teachers, professors, and all the learners present here. Ma'am, you have inspired us all by making us understand different aspects of mathematics which we need to reflect. The beliefs that we hold with respect to mathematics, tasks used in teaching mathematics, and reflection on pedagogy and resources used. Your innovative idea about having a growth mindset and how it influences our mathematics learning, as well as cultivating growth mindset in students and giving constructive feedback to motivate growth mindset in students was exceptional. As you had also mentioned, action and reflection goes hand in hand. We will try to inculcate what we have learned today in all the possible ways. Thank you once again for giving us your precious time and sharing your abundant knowledge with us, ma'am. Also, I would like to thank our principal, Dr. Susama Samuel, for giving us warm welcome with her views on reflective teaching in mathematics, and also our manager, Father Blaise D'Souza, for encouraging us. This webinar wouldn't be a success without our staff coordinator, Dr. Winnie Sebastian. So I thank her for giving me this opportunity and for all the countless efforts and coordination which helped us to make the event a success. Also credits to our formation team, Blitz, Newmill, Sarang, Suzanne, Saloni, Rachel, and Nilsima, who supported us from being behind the curtain to make this webinar flourishing. How can I forget our participants whose kind participation for bringing their experience around the table and engaging in such fruitful, constructive, and open exchanges throughout the webinar. Without you, this session wouldn't feel live. Looking forward to seeing you all soon again. Thank you.
Thank you, Olisa. I request Rachel or Saloni to come and give some instructions about the feedback form.
Yes, ma'am.
A gentle reminder to all the participants present here, link for the feedback form will be sent in the chat box of the Zoom meeting and in the YouTube chat now. Kindly fill it to get the e-certificates. Please note that we are keeping the form open till 7:30 p.m. So all the participants are requested to fill the feedback form before 7:30 p.m. Also, while filling the form, make sure that you enter your correct email address or the certificate won't be delivered to you. And also enter your name correctly because no changes would be done later. If you don't receive your certificate, please wait for 30 minutes and do check your spam folder. After 30 minutes, if you're still unable to get the certificates, then you can contact any of the students' coordinators regarding the issue. Thank you.
Okay, so thank you, Ruchi. And there are a lot of messages on the YouTube also thanking you. So thank you very much for this session. And I hope some of us join the course also on reflective teaching in mathematics. Yeah. So thank you, everyone, and have a nice weekend.
Yeah. Thank you, Vinny. Thanks for inviting me.
Yeah, thank
Bye,
you.
everyone.
Bye. I have the same sticker which you have on the wall in my house also.
Good to know.
Yeah,
Connections.
Nice. Yeah.
Okay.
Okay. Bye. Bye, Father.
Bye bye. Thanks a lot.
Ma'am, you have posted the link on the YouTube.
Yes, yes. Just check, no, Saloni once again.
Okay, ma'am. Yes, ma'am. I'll do that.
Hello, Vinny ma'am.
Yes.
The video which was shown at the end of the session, we couldn't see that entire video.
Yeah, so you will find it on that Clicks OER, website by TIS, no? That ma'am has put up that website link, no? So in that it will be there.
Okay, can you share all these links on the math group, WhatsApp group?
Okay. She has put only one link, no?
And about the sessions also, the course.
Okay. So I'll share it in the group. Okay.
Okay. Thank you so much. Bye.
Okay, should I end the meeting now?
Yes, ma'am.
Saloni, everyone is in. Okay, bye.
Yes, ma'am.
Bye. Thank you very much, all of you. Thank you.